water. I really wish it was hot Dunkin' Donuts coffee. Somebody's going to give me a sponsor someday. I don't know when. Anyway, guys, I'm Dow back. I'm on day one, and I'm doing homework for day one. So this is help for homework. If you haven't done the homework already, try it on your own, please. Come on, man. I'm not going to do this. This is all the notes for day one. Seems like a lot of notes, but it was quick. A lot of quick notes. Day one. Okay. So hopefully you had an opportunity to try these on your own. This shouldn't have taken you too long to finish. There's only a few hard questions on this homework, I believe. So the question says, which of the following statements is true? Explain your choice. All functions are relations, or all relations are functions. So if you remember our diagram from before, we had relations out here, and we had functions in here, right? So wouldn't you all agree that all of these functions are inside of relations? So this is the right answer, right? So functions are relations that each x has one and only one y value. In other words, functions are all relations. They're just very specific relations. Okay. The functions shown below, including the table, we got this pair and this pair. Which one will result in it no longer being a function? So remember, we're looking for something that might give us repeating x values. So if I put in -3, 2, I already have a -3. So that would make it not a function. How about this one? 2, -3. Are there any 2's here? So if I was to plug in 2, -3, that would still be a function. So the answer is -3, 2. Why? Because we have repeating x values. Given the table, represent as a mapping function and a graph. So the first thing I want you to do is graph it. 1, 2. You generally don't have to put a scale in if it's just going to be 1. In fact, you don't have to put a scale in if it's going to be 1, but I like to put them in anyway, 1 on 1. 3, 4, 1, 2, 3, 1, 2, 3, 4. 1, 6, 1. That's 2, 4, 6. And 3, 8. And this is not a point on the graph. Okay. And as a mapping function, input, output. Let me move that over so my big old head's not in the way. So there's only 2 different inputs. You wouldn't repeat you would not repeat the 1 and the 3 just because you see it on there twice. These are your only 2 inputs. And my output is 2, 4, 6, 8. 1 goes to 2, and 1 goes to 6. 3 goes to 4, and 3 goes to 8. And just in case you're wondering, this is not a function. You see the repeating x values, 1, 1. You see the double arrows. You also see the failing of the vertical line test. Lots of different ways to see that that's not a function. Not sure I asked that. Oh. So is number 3 a function? Why or why not? No, since the numbers 1 and 3 in domain have more than one output value. All right, so the domain, very simply, 1 and 3. Do not repeat domain. Do not repeat range. Range. You notice I just put in D and R. That's fine. 2, 4, 6, 8. Determine if each function below is odd, even, or neither. If it's a function, determine if it's odd or even. So first thing I do is decide if it's a function. This is, yes, a function. But if you were to graph this, you would find out that this is neither. This is a function, yes. And it is odd. Why? Because if you spin your paper 180 degrees, it lands back on itself. It also passes the vertical line test, right? This one is a function, passes the vertical line test, and it is symmetric with respect to the y-axis, so it is even. This is a function, yes, but it's neither. It is neither. If you put a line here, you don't see the same image. You don't see this mirrored over there. It doesn't happen. This is a function, passes the vertical line test, but it's neither. Right? Because if you spin your paper 180 degrees or you throw a line of reflection right here, it will not be on, it won't be a reflection. This is, yes, it's a function. Let me make sure. Open circle, open circle, open circle, open. You just got to be careful with open circle. And this is neither. This is a function, but it's neither. This is a function, and it's odd. And this is a function, and it's even. Why is it even? Because if I draw a line right here, I see the mirror image on the left and the right. Quick evaluation. F of negative 1, because I'm asking you to plug negative 1 in, equals 2 times negative 1 minus 1 plus 5. Well, this is negative 1 minus 1, which is negative 2, but the absolute value of negative 2 is 2. So 2 times 2 is 4, plus 5, which is 9. Running out of space. Okay. Negative 1 squared is positive 1. Positive 1 times negative 4 is negative 4. Negative 6 times negative 1 is positive 6 plus 11. So we have 17 minus 4, or 13. And the last one, h of negative 1. 7 times negative 1 plus 19. So this is really negative 7 plus 19, which is just 12. All right, we got to turn it odd or even. We got to do it algebraically. I could graph these and see, but I got to do it algebraically. So what I want to do is I want to test f of negative x. Now this has an exponent of 1, so it's probably going to be odd. So I end up with 3 times negative x, which is just negative 3 of x. So this is going to be odd. So since f of negative x equals negative f of x is odd. All right. This has an exponent of 3, which is odd, and 1, which is odd. So this is probably going to be an odd function as well. So we're going to do g of negative x equals negative x cubed minus 6 times negative x. Okay, so negative x cubed is negative x cubed. And negative x cubed times negative is positive x cubed. That's a little weird. And then negative 6 times negative x is positive 6x. So I look at it and I say it's not the original, so it's not even. I'm going to factor out a negative because I recognize they were odd, so it's probably going to be odd. And that last step with an odd is to factor out the negative. So I'm going to factor out that negative. And then I'm going to look at this piece right here. Is that the original? It is. So this is an odd function. Since g of negative x equals negative g of x. G of x is odd. All right, last one. H of negative x, 10 negative x to the fourth. See how they're even, and there's nothing here, so I'm not sure what's going to happen, but it's probably going to be even. Oops. Oh, I had a big sneeze there. So negative x to the fourth, since there's 4 of them, and if it's an even with negatives, that means it's positive. It becomes positive. So this is just positive 10x to the fourth minus, this is even number, so this just becomes positive x squared. So this becomes minus 3x squared minus 7. And since this is the same as the original, this is an even function. So since h of negative x equals h of x is even. I should have showed you an, and maybe I'll do that in class, one that's not, one, by the way, one that is not would be something that looks something like this. If you were to get a function, let me do this in black for you. If you were to get a function like g of x that looked like this, 3x to the fourth minus 2, oops, I can't use black, go to white now, 2x cubed minus 3x squared plus 5. Do you see how it's got a mix of odds and evens? That would be one that's neither. That would be one that's neither. All right, that's it. That's all she wrote. 12 minutes of homework.